Hey guys, let's look at something called apparent weight. So let's just say that, okay, there's an elevator, there's a person in the elevator, and I'm going to give the mass of the person as 60 kilograms. We're going to say the acceleration of the elevator is 0. Okay, that means it's either staying still or moving constantly. Okay, so there's no acceleration, there's no change in velocity here. Okay, so if I were to draw this as a free body diagram, okay, I would make a dot here for the person. I know it's not accelerating, so these two are going to be equal. Okay, so the weight is mass times gravity, and then the normal force is the opposite of that. So let's just figure out what that is. The weight right here is 60 kg times negative 9.8. So the weight ends up being negative 588 newtons. Okay. And then the normal force is the opposite of that. Okay, it's not accelerating, it's staying still or moving constantly. So it'd be 588 newtons up. That's what the person feels on their feet, is the 588 pushing up. Now, we know elevators don't just stay still. We also know that elevators accelerate. So let's look at the situation two different ways. Okay, we're going to look at acceleration upward, and then we're going to later look at acceleration downward. So let's say instead of the a's 0, let's say the acceleration becomes 2 meters per second squared up. So this elevator is pushing up. So just think intrinsically. Okay, if I'm pushing something up on his feet or her feet, okay, he or she is going to feel like an increase in their weight for the time that you're accelerating for. So if we keep that into consideration, the apparent weight is going to feel like more. So let's just draw a free body diagram to show what that might look like. And we've got everything else we need here, except the A is now 2 meters per second up. All right, so a free body diagram. Okay, we still have mg, which is 588. Okay, we still have the normal force, which is 588. Okay, but in this case, it's accelerating upward. So I got to find out what force. I'm getting an additional force here. Okay, we'll call that this here. The additional force is the mass times the acceleration. So if we got 588 newtons plus the mass of the person times the new acceleration in the upward direction. Okay, I've got a new, what seems to be an apparent weight, normal force, of 588 plus the 120. So our new normal force is 708 newtons, and this also can be called apparent weight. So all we did was we just took what we had, we added a little bit of an upward force here because it is accelerating upward now. I've included this, and the arrow on this side looks a little bigger, okay, which means that unbalanced forces accelerate. This is definitely an unbalanced force. This side is accelerating greater. Okay, so that person feels like they have a weight of 708 newtons, but we know that their weight is only 588. Okay, now let's just change a situation where the acceleration is in the downward direction. All right, so again, Weight is there. Normal force is here. Okay. Now instead of the acceleration going up and adding to it, okay, it's going to take away from it. So this downward arrow will represent a minus sign. So what I'm going to do is I'm going to subtract mass times acceleration of the object. So 588 minus 60 kilograms times 2 meters per second squared. Now, there's a minus here because this 2 is what gives us the minus. Okay, so I just put that because I know that the acceleration is going to be negative. So we intrinsically think about it. If it's accelerating downward, we're going to experience a less force on the feet. Okay, so we know the weight's 588 still, but the apparent weight in this case is going to be 588 newtons minus the 120, okay, because we got this 120 on this side, okay, and so what happens is this is it's a 468 newtons. So the new normal force is 468 newtons. Okay, so we got 468 pushing up. We've got 588 pulling down. Okay, that just means that it's accelerating down, which makes sense. And this is our new apparent weight. Okay, this is the normal force pushing up on the person's feet. All right, so a couple things to get from this video. Number one, accelerating objects, the weight can be found very easily. Weight's mg, the normal force is the opposite of the weight. Accelerating objects up mean that the normal force or the apparent weight is going to feel greater. Accelerating down, we subtract from that, so the normal force or the apparent weight is going to feel less. Okay, so you've got a few problems that you can work out on your own in the homework. Again, if you need any help, just see me and we will talk, but that's the situation.